Okay, welcome. We're going to be looking at the notes for the absolute value function here. I've already got it started, so you can actually see here that the absolute value function looks like this, and it's got those two lines down there. What it is algebraically, however, is this equation here, which is actually y equals the square root of x squared. Now what I've got is a couple examples of what it does to numbers. Okay, so if I've got just the number positive 3 in here, and you do those things to it, you'll have 3 squared square rooted, which is 9, square root of 9 is just 3. So funny enough, the positive number that goes in just comes out as it is. However, if you put a negative number in there, like negative 3 and square it, it'll become 9, positive 9, square rooted, and it becomes positive 3 as well. So what it actually really does is positive numbers it just leaves alone, but if you've got a negative number, it will actually turn it into a positive. So if we quickly sketch it, what you'll find is numbers like positive 3, when you sub them in to the equation y equals modulus x, you'll just get 3. Positive 2, again you'll get positive 2, positive 1, 1, 0, it doesn't matter. However, when you put negative 1, just like negative 3, negative 1 squared is positive 1, square root is just 1, and the same with 2. And so graphically what it looks like is this. Okay, so there's the graph of y equals modulus of x. What you've got down here is a special point, which is called a cusp. And we'll just write that one down. But what else is interesting is the line really represents the line y equals x. And we'll talk about this a bit more, but what actually happening is, or when we've got this absolute value function, all the y values that were negative don't exist anymore. So, for example, if you look at this value here, which was minus 1, when you subbed in x equals minus 1, it would have given you an answer of normally minus 1, but because of the modulus, it flips it over here. Okay, so what you're actually getting is a reflection of all those negative y values in the x-axis. Alright, now with regards to transformations, we can just quickly write those up. So we've just got this, you've seen this so many times now, we really don't need to explain it, so I'll just write it down. This is your dilation of A from x. It also can be reflection. This is left, right, and this is up, down. Okay, obviously, well, it's up, down, you can fill that bit in. Obviously you've got to remember that with these transformations there's also the dark side, but we'll just leave that alone for now. Alright, let's see how it goes. So we're going to do this one. So we're going to do one of the questions, very first types of questions you'll get in the question booklet. Dilation of 2 from x-axis. What that's going to do is, if you want to look at this graph, it's going to push up all the y values by 2. It's going to make it skinnier. Just always think about the parabola. It's going to make it skinnier. We're going 4 to the right, and then 3 up. Okay, so when you're doing parabolas, it's easy to find the turning point by these two values. Guess what? You can find the cusp point really quickly with these two as well. So you can just quickly see that the cusp point is actually moved 4 to the right here, and then 3 up. It's going to be a bit skinnier. I'm just going over my notes there, but I don't want to use the next page. The only other thing missing is the y-intercept. Okay, and the y-intercept can just simply be by subbing x equal to 0. Now if you sub in x equal to 0, I'll just put it down here. Y is 2 lots of absolute value of negative 4 plus 3. So it's really 2 times 4, because that becomes positive. So it's 2 times 4 is 8, plus 3 is 11. Okay, apology on your notes there. Alright, next one to look at. This is a question that you'll find is probably number 2 or 3. And these ones, there's a very easy way to sketch these. Okay, now I've got something silly over here, but just to help explain it. Like if I've got an equation saying y equals stuff, if you just do this to it, just like I was saying earlier, it just simply means whatever the original graph is, you're going to reflect all the y values that are negative in the x-axis. So, you know, if I've got something that looks like this, okay, I'll just do a dotted line. If I actually did put a modulus around it, what will happen is, okay, you'll get the same graph, but all the negative y values are just reflected. Alright, so why don't we have a look at this one? So the first step is actually to sketch this guy, which is not a tough one now, hopefully. Okay, so to sketch that, we know that we've been moved 1 to the right, so x equals 1. We still have a y-intercept of 0 because it's plus 0, so it's y equals 0. Alright, and we've just simply got a graph, no dilations, it's just been dilated away or from the x-axis a little bit. Okay, we've got a y-intercept, so if you quickly sub that in, you've just got, when that's 0, you've got -2. Alright, now, when you put the modulus around it, what will simply happen is all the y values that was pumped out that were negative don't exist anymore, because the modulus will make them positive. So if you've forgotten, something like that, now becomes that. Okay, so the answer here, so when you sub in x equals 0, you're not going to get -2 anymore, you're going to get +2, and so forth. Okay, so if we reflect all those values, quite interestingly enough, your final graph is this one. Okay, this doesn't exist anymore. Alright, so it's quite an interesting graph we've got there. Okay, the last thing to put into your notes to start off with, and the part B of this will actually have, well, the second video will actually have more examples, but it's the definition of a hybrid for modulus function. Okay, it's a little hard to read there. Now the definition follows like this. You can really write this as two separate functions, and it simply goes like this. Just like we used this example for, if you had +3, okay, it doesn't change it. Okay, so what we're going to do is just say, look, when the thing inside the modulus is positive, see that sign there, basically it's just going to be the same answer. Okay, because remember that was just the same answer. However, when we put a negative in there, we did all that clever stuff earlier, but you don't need to do that. I'll show you a really quick, easy way to turn it into +3. You know the answer is +3, but you can just simply multiply that number by -1. So when the value inside is negative, you simply go -1 times what's inside. Okay? Now you can look at that graphically too. There's two graphs here that make up this one whole graph. Let's have a look at it. So when x is greater than 0, we're talking about this domain here. It's just y equals x. That's what it means. If you've got y equals x and y equals -x. And when x is less than 0, which is over here, you've got y equals -x. Okay, and surprise, surprise, it looks like that. Now there's a little more information about letting this equal 0 as well. Look, we'll just leave that alone. Okay, this interpretation can be argued to be different, but we'll just leave it like that. That's what they do in the book. Okay, an example. So we'll quickly do this example, and this will be the last part of this video. So how do you tackle this as a hybrid? Well, first off, you've got to realise that this is the stuff that we're talking about, what's inside the modulus. So when the thing inside the modulus, which is that, is positive, we know that we're not going to touch it. Okay. Now when there's numbers around it, they just go around it. Okay, so there's just a 1 out the front, so you just have a 1 times. If there was a 2 times, it'd just go out there. But the 4 just gets tacked on at the back. Now if that thing inside is negative, okay, what you need to realise is we times it by -1 to make it positive, and just tack on everything else around it. Now you just need to tidy that up. Well, I'll show you how to graph one in the second set of videos. So just pretend that's an equal sign, and you just take 1 to both sides. You'll get x. X is greater than -1, and you'll get x is less than -1. Tidying this up is just x plus 1 take 4, which is x take 3, and this becomes -x take 1 take 4 take 5. And if you actually graph that, it would, this would be easy to do by transformations. Just if you graphed modulus x, moved it 1 to the left and then 4 down, and then quickly sketch that, you'd find that a heck of a lot easier than trying to sketch it like this. But we do have to learn this method. Okay, that's the first video. That's the notes done. In the second video, there's more examples of the questions that you'll get in exercise 2F. Thank you.